Welcome to The Explainer. All right, let's talk about one of the biggest challenges in machine learning today. How do you get from a cool little experiment to a rock-solid system that runs in production? It's one thing to train a model once in a notebook, but making it reliable and repeatable, that is a whole different ballgame. So here's our game plan for this explainer. We're going to start with why this is such a hard problem in the first place. Then we'll talk about the solution. We'll meet the key players, the tools that actually get this done. We'll see how they fit into the bigger MLOps picture, and we'll wrap up with how you can pick the right tool for your project.
You know the feeling, right? You've trained a model in a Jupyter notebook, it works great, your accuracy is looking fantastic. But then, what happens when you have to make that thing work reliably, day in and day out, in the messy real world?
And this right here is the million-dollar question. That one successful run in your notebook, that's just the tip of the iceberg. The real world throws all sorts of curveballs at you. You need to schedule things, handle random failures, scale up when you get more data. It's just a lot more complex.
And this perfectly shows the huge gap between that simple experiment and a real production system. You need all this stuff. You need automated retries when something breaks, you need to schedule your training to run every night, and you've got to be able to scale it across a bunch of machines. A manual, notebook-first approach just falls apart here. It's way too fragile.
So how do we fix this? How do we build something that can actually handle all that complexity? Well, that brings us to the solution, and it really comes down to two key ideas: pipelines and orchestration.
Okay, first big idea, the training pipeline. Seriously, just picture a factory assembly line, but for your model. It's this predefined, totally automated sequence of steps that guarantees every single model gets built the exact same way, every single time. It's all about consistency and making things repeatable.
And this is basically what that assembly line looks like. You start with your raw, messy data, and it moves through each of these stages: preprocessing, training, validation, until you get a finished, polished model at the very end that's ready to be deployed. Each of these is just one automated task in our pipeline.
This comparison really hits it home, doesn't it? Orchestration takes all of those painful, manual, error-prone tasks and just puts them on autopilot. It turns a brittle, hands-on process into a truly robust, observable engineering system. It's a total game changer.
Okay, so now we get why we need orchestration. Let's meet the big three, the industry-leading open source tools that actually make this happen. Each one has its own personality and is built for slightly different kinds of jobs.
First up, we've got the OG, Apache Airflow. It came out of Airbnb and has been the veteran in this space for a long time. It is a powerhouse for scheduling and managing really complex data jobs, especially batch ML pipelines. Think of it as the reliable workhorse for anything that has to run on a set schedule.
So Airflow's biggest strengths are its incredible scheduling capabilities and its amazing logging, which gives you a ton of visibility into what's going on. But here's the catch. It wasn't really built from the ground up for modern deep learning. Things like native GPU support, that's not its forte.
All right, next up, Kubeflow. If Airflow is the general-purpose workhorse, Kubeflow is the specialized, high-performance race car for heavy-duty ML. If you're doing deep learning, large-scale distributed training, and you live inside Kubernetes, this is the tool that was literally designed for you. It's a whole lot more than just a scheduler. It's a full-on ML platform.
The power you get with Kubeflow is just incredible. I mean, first-class GPU support, built-in model serving, it's made to scale. But, and it's a pretty big but, all that power comes with a price. There's a much steeper learning curve, and you absolutely have to know your way around a Kubernetes cluster.
And that brings us to our final tool, Perfect, the modern challenger. This one is designed to be Python first and just, well, easier to get started with. The whole idea is to make orchestration feel like you're just writing a normal Python script. It's really built for developers who just want to get things done without a lot of fuss.
So the big win with Perfect is its amazing developer experience and how fast you can get up and running. I mean, you can have a pipeline going in just a few minutes. It's an awesome choice for smaller projects or just for trying things out, but it's not quite as mature or ready for massive enterprise-scale jobs as, say, an Airflow or a Kubeflow.
Okay, so an orchestrator is obviously a huge deal, but it's not the whole story. It doesn't live in a bubble, right? It has to plug into a bigger system. So let's zoom out and see how it connects to the complete MLOps architecture to build a real end-to-end system. And this is that system. The orchestrator is right there in the middle, acting like the central nervous system for the whole operation. It connects everything together.
It sees when new data gets versioned, it kicks off the training script, it tells your experiment tracker to log all the results, it registers the final model, and then it can even trigger the deployment. It's the conductor for the entire orchestra.
All right, we have covered a ton of ground. So let's bring it all home with some clear, practical advice on what you should be doing, what you should probably avoid, and, most importantly, how to choose the right tool for whatever you're working on.
Okay, let's nail down some best practices. Number 1, version everything. I don't just mean your code, I mean your data too. Use something like DVC. Number 2, use Docker to containerize your environments so they're always reproducible. And finally, automate, automate, automate. The whole point is to build a reliable pipeline and get your production work out of those manual notebooks.
And on the flip side, these are the traps that lead to systems that are fragile, unscalable, and impossible to reproduce. You know, the biggest one I see time and time again is just relying way too much on Jupyter notebooks for production jobs. Notebooks are for exploring, orchestrators are for producing.
So how do you actually choose? Let's make this super simple. If you've got a smaller project and you just want to move fast, start with Prefect. If you're dealing with really data-heavy scheduled workflows, look no further than Airflow. And if you are all in on deep learning and Kubernetes, Kubeflow is absolutely your answer.
I want to leave you with this one final thought, because I think it perfectly sums up everything we've talked about. This is the big mental shift that orchestration gives you. It's about moving beyond those one-off R&D experiments and starting to build reliable, automated, and truly scalable engineering systems. Thanks for watching.